All right, everybody, welcome back. Today what we're going to do is we're going to talk about piecewise functions. Now, piecewise functions are exactly what they sound like. We're going to take different pieces of other functions and put them together to make one function. All right, so it sounds really complicated, but there really isn't that much to it that you guys don't already know. All it is we're going to graph full functions, erase parts of it to keep certain pieces, and then probably repeat that process 2, 3, 4 more times. So this is an example of a problem we might see. The piecewise function is called f of x, and it's defined with three different functions here. We've got a horizontal line, a quadratic, and a regular line, and then we have our domain restrictions on the side. So just to kind of point this out, we've got our equations, and then our restrictions. I'm going to graph each one in its entirety, and then I'm going to only keep the pieces that are outlined over here on the side. So the first one is y equals, our output is -2. That's going to be down here on the bottom. Now, we don't want the entire thing. We only really want from between -3 and -1. So there's -1 right there. There's -3 right there. So we can basically get rid of everything else. All right, and then I don't need that highlighted portion anymore because it's just telling me where my values are. So this is the part we're going to keep. Again, it's very small in this case, but what we want to make sure we're doing is we want to include 3 and exclude -1. So what that means is when x is 3, we want to include that point, and then when x is -1, we want an open circle. So that's what our first piece is going to look like, and that's essentially how the rest of this is going to go. The next thing I'm going to do is graph a quadratic. Now, this quadratic has a reflection. It's a vertical reflection. So instead of our parabola opening up, it's going to be the exact same, but opening down. So it's going to look something like this. Now, we don't want the entire thing. As we could see, technically right here, and really for these pieces, we are overlapping, which means this wouldn't really be a function. So it's not something we want. But we are only going to keep between -1 and 2. So again, my -1 is right here. My 2 is right here. I'm going to erase outside of those values. So, probably going to mess up my other line here, but we're going to go to right about there, and then right about there. So I'm going to fix my green line real quick. And then this is the function we're going to want to keep, the piece of the function we want. Now, going back to those restrictions, I want to include 1 and include 2, which means both of these are going to be filled in circles. And that is it. All right, so we've got our second piece done. The last thing I want to do is create my line, which we've got down here in purple. And so I'm going to do that. We've got a y-intercept of +1 and then a slope of 2. Put that point a little bit higher up so we don't ruin some of these. And so our line is going to look something like this. All right, now I don't want the entire thing, so I'm going to erase the pieces that are outside of this restriction. I only want between 2 and 5, so it really leaves us with from here to here, and I'm going to erase everything else. And again, I got to fix my green line here. And then I can fix my pinkish, and now erase all of this. All right, so now what we really just need to do is decide if we're going to keep the values when x is 2 and 5. And since both of these are not including those numbers. These are going to be open circles there and open circles there. And then this is our piecewise function. So again, there's kind of a lot of work that goes into it, but none of it is super complicated. We're going to graph different functions and then erase parts that we don't need. Now, on the flip side, we have this situation where they give us the equations and the restrictions, and we need to go ahead and do the graph on our own. But we could also have the other side where they give us the graph, and we need to write the equations and the restrictions. Now, same idea. It shouldn't be overly complicated because we should know how to write equations for each of these situations. So I've got my purple equation and its restriction, green equation and its restriction, and then we have the red equation and its restriction. All I need to do is come up with those equations. So if we look at our purple, we can see we're going up 1 and over 2, up 1 over 2. So that means we have a positive 1/2 slope. And we don't really have a y-intercept at the moment, but if this were to continue, we would cross right at -1. So that tells me we have a -1 right there, and that is all we're going to need to do. So in theory here, I was just kind of extending this line to see what our y-intercept would be. Again, I don't have one now because of my restriction, but I wanted to see where it would cross our y-axis. Now, the next thing I need to do is talk about the x values I want to keep. If you take a look, we've got between here and here. Well, that means we have an x value that is between, what do we have, -2 and 3, 4, 5, 6. And both of those are filled in points. And what that tells me is I want to include those values. So my inequality symbol is going to have the equal to part in them. Now maybe it'll be easier if I erase this and redraw it underneath. But that's what this one's going to look like and make that a -6. That is the first part. Now I'm going to do the same thing for my green one. My green one is a horizontal line at y equals 1, 2, 3, 4. So all I need is the number 4. And then, again, my x values are between -2 and +2. And I'm not going to include the value when x is -2. But I am going to include my filled-in point at 2. So that is my second part. And then my last part, this is an absolute value function. As you can see, we're just shifted 1, 2, 3, 4 to the right. That is the only transformation that's there. So we have the absolute value of x minus 4. That is our red function here. And I've got between 2, 3, 4, 5, 6, and 7. So between 2 and 7, we're talking about the x values, right? So x goes in the middle. And I am not going to include 2, so no equal to part, but I am going to include 7 because that is a filled-in circle. And this is my piecewise function. So again, none of it should be totally new for us. We are just putting together pieces that we already know. Now, part of the hard part that some of us are going to deal with is our domain restrictions. If you notice, if you start with the lower value and go to the higher, our absolute value functions, or inequality symbols, all face the same direction with x in the middle. So it is always going to be the case if we go from low to high, which is what we should do. Now, the last part I want to talk about is evaluating piecewise functions. Essentially a question like this, they're saying, hey, you want to take that piecewise function and you want to plug in 0 for x. Well, the problem is I have 1, 2, 3 different equations. How do I know where I'm supposed to plug in 0? Well, we're talking about x values, so I want to plug in an x of 0. So first I check to see, does x fall between this restriction? It doesn't, right? 0 is not between -6 and -2, so we move down. Does 0 fall between -2 and 2? It does. So that means that I'm going to plug in my x value of 0 into this equation. Well, there's nowhere to plug it in, so my answer here is only going to be 4. The next one is going to be pretty similar. I want to plug in 5. I got to figure out, does it fit into this domain restriction? No. Does it fit into this one? No. It fits into our last domain restriction. So what I want to do is take this equation, which I can do on the bottom here to make this a little bit easier for us. And I am just going to plug in 5. So I have the absolute value of 5 minus 4, which is the absolute value of 1, which is 1. Now, let's confirm with our graph. If I go to where x is 0, which is right here, my function is all the way at the top there. That has a value of 1, 2, 3, 4. So that checks out. If I go to where x is 5, 1, 2, 3, 4, 5, my function is right there. That's where the point is, right here. And that point has an output, or y value, I guess you could say, of positive 1, which checks out with what I have over here. All right, so piecewise functions, all we're doing is we're graphing different functions. We're erasing parts that we don't need based on those domain restrictions. None of it should be overly complicated, but the problems do take a good amount of time because you are graphing 3, 4, maybe 2 different equations, and then you're piecing them together as you go. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out. Thanks.